All right, which graph matches this one? Well, the first thing, I'm looking at that numerator and thinking I am going to double check that to see what happens if I factored the numerator. So I'm thinking that's x minus 6 times x minus 6. And it's all over an x minus 6. So if you look at that, is that factored correctly? X times x is x squared. Negative 6x, negative 6x would be negative 12x, and a negative 6 times, yep, so it's factored correctly. Well, what does that mean then in terms of my graph? Normally, I would have said this is a vertical. But when it simplifies out, the simplified version is what creates your overall graph shape. Just the y equals x minus 6. Then you look back at your original problem and say, but the original problem would never really even exist if x equaled 6. So x equals 6 is just what's called a hole in the graph. So we need to graph the y equals x minus 6. So first of all, eliminate that one and this one. Those aren't linear equations. Which of the other two is x minus 6? There's a minus 6 with a slope of 1. That doesn't look like, that looks like a positive 6. So that would eliminate that. But then the piece that is still here that I wanted to point out, this x being 6, right here, there has to be a hole in the graph. That's meaning that if in my original problem, it simplified out of the problem, but for the original problem, if you did have x equals 6, it would be undefined. So we can't have it in the graph at all. But those are all the parts that come into play for 4.2.28. Rational functions, asymptotes, holes, x-intercepts, locations of the graph. And you know, just know you can always grab Desmos or something to help you double check your work.